All right, Brett. We're going to demonstrate this new calcium oxide, mag oxide procedure here.
So first thing we're going to do is add or weigh out 0.5 grams of this crushed dolo.
And that needs to be pretty accurate, right? Like
Yeah.
0.5 plus or minus something like 0.05.
Yeah, somewhere in there. So about 0.505. That's a good number to shoot for.
Okay.
That's just really touchy.
So this is, right now, he's weighing out the crushed dolo, which is prepared the same way as you would do a normal LECO test. So they run it through the crusher and then screen it, and that's going to be the starting point for this test.
So you add the sample to a beaker or a flask. Like so.
Okay.
Let's see. Next we'll add 10 mils of 50% HCl.
Okay. So are you doing, this is the calcium oxide test first, is that correct?
First we're doing the, we're making the main solution to test. So
Okay.
from this main solution we're going to use it to test for CaO and MgO.
Okay. Okay.
So, and it's a good little tip when you're measuring out your acids and whatnot. Put it in a bigger container so you can put in more and then pour into your smaller 10 mils, and then the rest can just be dumped back into the stock solution.
How big is that graduated cylinder?
This is 50 mils.
That's 50, okay.
And so once you add the acid, you're going to get a solution that looks a little like this. What do we do next here?
Basically the acid is kind of dissolving or digesting the
Dolo.
the dolo, yeah.
Just kind of swirl it around, try to get all the dolo that's still in there to mix in with the acid. But if that doesn't work, it'll just put it on the hot plate for a little bit until it evaporates.
What if there's some on the sides of that?
If there's some dolo on the sides, just feel free to add a little bit more acid just to get it off the sides, or you can just swirl it around like so.
Okay.
Just so
Keep swirling it so it goes up the sides and
yeah.
takes all the dolo in.
So now it's just going to sit there for a little bit. The goal here now is all the acid's going to evaporate off and it's going to leave like a white-yellow residue. So this could take a little, probably about 10 minutes or so.
Okay.
On a moderately high setting on the hot plate.
Okay, we can, what we'll do is we'll pause it right now, but I just wanted to point out that this new testing does give fumes off, like Brett mentioned, and that's why you want the fume hood here definitely running while you're performing the test. Okay. Okay, we're kind of getting at the end here where they're evaporating the solution, and it's gonna, basically it's starting to turn white, and it should, you know that you're done when it's all white and dry.
It's nearing the end point right now. So once all this bubbles and the gas goes away, it should just lead to a white-yellow residue.
Okay. And also, it's very important to make sure that you have your gloves on. Some of the chemicals, some of the acid could cause burns without
yeah.
that.
This acid right here, this will cause the most burns if you don't wear your nitrile gloves.
Okay. That's the 50%?
Yep. It's still a dilute acid, but it's just a 1-to-1 of acid and water.
Gotcha. Now you can see it's still a little bit of bubbling, but it's gonna
Let it go for a couple more seconds.
Yeah, it's going to go from yellow will disappear and it'll just be a whitish crust on the bottom. This is probably the most time-consuming part of the test.
Want to zoom in on the crust on you?
Yeah. Does that need a little bit more?
No, that'll be fine.
So that's what it's going to look like.
So now we're going to add a 10% HCl solution, which comes in this big container.
Okay.
All the chemicals can be found in the chemical cabinet just outside the lab.
So how much of that do you add?
Added 25 mils.
Okay, 25 mils of a 10% acid solution.
You'll notice some gases are beginning to evolve. That's normal. None of the gas is considered toxic, but it's very unpleasant to breathe in. So just kind of swirl it around, get all the residue off the sides so it's kind of a homogeneous mixture. So it almost looks like a water, but it'll still have a yellow tint to it. And from here we'll put it on the hot plate to heat for another 10 minutes. Just to boil out any impurities. And
is that pretty much 10 minutes exact that you want to go?
10 minutes exactly.
Okay. And eventually we'll have a timer.
We do have a timer, but for now it might be easier just to use the clock on the wall. So about 9:37.
Okay, well, we'll pause that for now. Okay, you're at the end of your 10-minute heating period.
Yep, so we're just going to take it off very carefully. The flask is obviously very hot. Set it down on the mat. We'll let it cool just a little bit. Swirling it on the sides just to get anything off the sides. Very nice. So from here, we'll have a more yellow solution than we did before. We're going to eventually get it into this volumetric flask. But in order to get it in there without it spilling, we're going to dump it in this beaker with the tapered end point so it's easier to transfer to the volumetric flask.
Okay.
Let's let that sit a little bit longer. So what this does is it helps make your solutions and it helps mix them together so they're uniform. You're going to put the solution into the volumetric flask, and then you're going to dilute with distilled water up to the silver line. I'll try to get up close so you can see it. There's a little silver line.
That's etched into the glass.
Yep.
So that's the 250 milliliter mark.
Yep. That's how you know you have 250 milliliters of total solution within the flask. And then to mix it, we're going to cap it with the stopper, like so, give it a little twist to ensure that it's sealed. And then we're just going to invert it up and down a couple of times just to mix it, along with you could swirl it a little bit, but inverting is going to be the best way to do it. So we'll do that now. Just so it's cool enough to touch and handle, just dump it into the beaker.
Do you have to add any distilled water for
yeah.
Just to...
You can rinse the sides of our flask just to get everything.
Gotcha.
Actually, this is what you should do. Just take one of these dispensers full of water and just squeeze water in there off the side so you get everything.
Okay.
Dump it in our flask. And then we'll just add water through the flask via beaker.
You just go slow enough so you don't spill any, and
a little more. There we go. So invert our flask, get it mixed together. Maybe do this about 5, 6, 7 times. You can do it as many times as you want. Mix it at least 3 times though if you gotta get the test done fast. So now we have our lime solution, and now we can test for CaO and MgO content.
okay. So right now you're filling the burette. It's a self-leveling burette. So when it comes to the top here, it's going to overflow into this waste bottle.
Right there, I just got the air bubbles out of the tip of the spout, so it's more accurate.
Okay. All right, Brett. Looks like you're getting ready to do the titration portion.
Yep. So first we're going to do the CaO and the MgO at the same time. Both tests involve the use of the lime solution that we made earlier.
Okay. Okay, Brett.
Yeah, so now we're going to do the CaO and the MgO together. CaO in one beaker and MgO in another. First we're going to add 20 mils of our acid solution, or lime solution I should say, that we made earlier. And each flask is going to get 20 mils. So to deliver 20 mils using a pipette, like so, we first place the pipette into the flask, squeeze the bulb. Let's see here, squeeze the bulb. You might have to pinch the A valve on top. See the little A right there?
Yep, they're all...
Pinch that and squeeze.
Okay.
To draw up solution, you hold this S valve.
For suction.
Yep. Then you'll see the solution come up here. And you're going up to these 2 little lines here. You want it to go right in between the 2 lines.
Yep.
For it to contain and to deliver 20 mils.
There's the lines right there. You can see the fluid coming up.
So right about there. Pull your pipette out. And then you can do 2 things. You can hold the E valve down to expel, which seems to take a little bit of time. Or for time's sake, you can pop the bulb off of the pipette.
And gravity takes it down.
Yep.
Okay. Okay, Brett.
This will be the second portion of the testing. Again, you want to go in between the 2 lines here. That's just fine.
You got to be a little patient that as that fills up.
And then just pop your bulb off and let her drain.
So if you overshoot your marks, you can, easily press the E button or for expel
Yep, you can
to
use
get
the
where you
expel
want.
back into the flask.
Okay.
So now we're gonna dilute our sample to 150 mils of water for the CaO. And then
That's not 150 of water, but
no, you dilute to 150.
okay. So you're watching on that flask till you get up to 150 total.
And then for the MgO,
Okay.
you dilute to 100 mils.
So it's just easier pouring from a beaker to the flask instead of, you know, the whole jug of water.
Yep, just keeps everything kind of cleaner.
Yep.
So first of all, before we get into the CaO, which is a little bit easier to do than the MgO, we'll do the MgO, and we'll talk a little bit about these bottle top dispensers first. So these dispensers, up on top here, you can set any given volume that you desire between 1 mil and 10 mils of solution.
Mm-hmm.
And in order to get to the desired solution, which I believe for the 30% triethanolamine, we need to add, what was it here? 10 mils. So in order to deliver 10 mils, you slide the little plastic clicker here.
Yep. And you can see the tab or the pointer.
Yep.
On the side of it.
Down to 10.
Okay, so that one's set.
So now this is set to deliver 10 mils. For the ammonia buffer, we need to set it to 2. So that should be good to go.
And once you do the test, it should always stay at those settings, right?
Yeah.
Okay.
So you'll notice that the bottle top dispensers are pointing upwards right now. That just means that there's no solution in the stems. Before using the bottle top dispensers, turn the dispenser 90 degrees clockwise so it points like so. And what we're going to do here now is we're going to calibrate the dispenser by pulling up on the handle and then just delivering it back down into the solution. This calibrates it by not getting any air bubbles in your volume, so you know you're accurately delivering 10 mils every time. And it's a little easier if you set it to a smaller volume first so you don't suck up as much. And you do this a couple of times until you see that there is no air bubbles in the plunger here.
Okay.
So once you see that there are no air bubbles in the plunger, you're good to go. And from there you just turn it another 90 down into the downward position. And from there, you can adjust it to your 10 mils for triethanolamine.
Is it good to go then for the rest of the shift?
Yes. It's good
Okay,
to go
so-
for the rest of the shift.
So this is only you know, you do it once at the beginning of your shift or before you do your first sample.
Yep. Just to ensure that everything is calibrated. Okay. So now that our bottle top dispensers are fully calibrated, we can add our solutions. So we need to add 2 mils of the ammonia buffer and 10 mils of the triethanolamine. And it's important to draw the plungers up slow so you still don't generate any air bubbles. Just because you do it
Yep.
one way, you just want to make sure you do it very slow just to make sure that everything is still good to go.
And the nice thing about these dispensers is they're very accurate.
Yep, very accurate. So now the only thing left to do for the MgO now is to add some indicator. And for the MgO, we're going to use Calmagite. This Calmagite indicator is just a little bit of Calmagite powder, which is found in the chemical cabinet, and water. So all you do now is you just add a couple drops of your Calmagite. Right, 2 or 3. you're really looking for a faint color, a faint pink color, kind of like you're using phenolphthalein. So it should look something like this.
Okay.
Once you get your desired shade, you bring it on over to your burette, slide it down a little, and let it dispense.
In the future, we're going to have a stir plate here, but you can also do it by hand. As you can see, he's stirring it by hand. And you can go faster at first.
Yep.
Just like our other titration test, because you know about when you're getting close.
Yeah, you start to get close to the end point when you reach about 73 milliliters. So you can kind of swirl it around and let it be wide open until you get down to about 72 to be safe, and then back it off and swirl until you reach your desired end point. And right now we're about 60.
Okay. And the end point color.
Should be looking for a baby blue color.
Okay.
So now we're starting to get down to 72, 73 range. Down to eye level, just so I can see. We'll start getting it down to about a drop by drop. Pretty soon here it should begin to change color. Okay.
Starting to see it.
Yep. We kind of overshot it a little bit of our 73 to 74 range, but all in all, this is the color you should be trying to shoot for. This light blue.
And it should remain for, at least a minute.
Yep.
If it doesn't, you're probably 1 or 2 drops away of.
And a little tip to see the color a little better. You can slide a white piece of paper underneath it to really bring out your blue color, or you can hold it up on the background, whatever you prefer to see.
Okay.
So right here we're at about 78 mLs, and that's how you do your MgO titration.
Okay, right now Brett is filling the burette for the next mag oxide test. And again, the level is self-leveling.
So once we get done with our magnesium oxide test, MgO, we can go to our CaO. And we already prepared the 20 ml aliquot to the lime acid solution, and it's diluted to 150 mLs of water. So where this differs from the magnesium oxide test, the calcium oxide test uses 4 mils of potassium hydroxide. And in the future, this will have a bottle top dispenser as well, once we get the new lab put in. So I'll just pour a little bit into your bigger graduated cylinder to pour into your smaller graduated cylinder. And again, we're going for 4 mils. You can kind of ballpark it, 4 and a quarter, somewhere in there. This is just to adjust the pH or so, to make it a little bit more basic. And along with the potassium hydroxide difference, where you're going to use a different indicator as well. This is hydroxy naphtha blue. It comes like calmagite in a powder, and it's a pre-made solution of the indicator and water. So we got a couple drops or so in here.
Looks kind of reddish at first.
Yep. It's going to be the same kind of idea of purple to blue. Can add a little bit more of this just because the solution is a little bit weaker. That's a little too faint, so we'll add a little more. Yeah, that should work. You're really looking to get the same color you had for the calmagite.
Yeah, like a light pink.
It's like a light pink, just like phenolphthalein, just like what you've always been using. So now that our solution's ready to go, you just bring it over here and do another titration. Nope. So for this one, you're going to want to let her drain until it gets down to about 20-22 or so. That's when you can kind of slow down and watch where it goes here.
Right now you're getting close to 20.
We'll slow it down, give it a little stir. We'll slow the stream just a little bit. Starting to see a little bit of an initial color change. This one for the hydroxy naphtha blue, you're gonna want to add a little bit more indicator than what I just did. So maybe a couple more drops, or maybe even another syringe full, just so you can see the end point. This one's very faint, and right now it's more of a faint purple blue. However, that's the idea. You're gonna want to get it to about this. It's gonna be about the same color endpoint as the MGO. But for the purpose of this, not enough endpoint was added, so it's pretty faint. You can't really see it.
It's definitely blue, but
without the untrained eye. But yeah, for the endpoint, just make sure just add a little bit more naphtha blue, and that'll be outlined in the procedure, which can be found online as well.
And then, of course, you want to make sure that you're recording these burette measurements.
Yeah, but it's important to record the burette measurements, because in the end you'll use your volume of EDTA delivered to find quantities, percent MGO, percent CAO, and all that good stuff to find our ultimate answer.
And you have right now you have a couple waste jars here, but yeah, can you speak to that?
Yeah, so when you do the test, there will be 2.5 liter amber jugs nearby that'll say waste from mag oxide. It'll be easier for you to just dump your titrant waste into these jugs, and by talking with the water treatment plant, we are certified to dump this down the drain. So once these fill up, just dump them down the drain and maybe give them a rinse out or so, and you're good to go.
Okay. All right, Brett. Thank you very much.